Okay, so this video is really more of an introduction to what we're going to be starting here. So we're going to be moving away from simulation and starting to get into the heart of this course. Now, we will have a project that I'll be posting soon related to simulation, but you'll have time to get that done, but you'll want to make sure to work on the project and not wait for the day before it's due. Um, because you'll want to be able to work on it, ask me questions, things like that. Um, so what I'm doing here is kind of giving you an overview of the type of things we're going to need to learn here, because the next goal is to be able to do a layout for a circuit. Now, it sounds maybe complicated or simple to do depending on your perspective, and it's not difficult, but there are a lot of steps, and it's very easy to forget one of the steps. So we're going to do this slowly. What I'm going to do first of this video is just kind of introduce you to everything that we're going to have to do, and then we will kind of take it step by step to get to our actual laying out of a circuit. And then once we do that, we will actually be soldering. And to do the soldering, what we'll do is we'll have some lab times that are scheduled where we'll have one of our lab assistants there that can help with soldering. I also have a video showing you how to solder, but then obviously the lab will be where you would be doing the soldering yourself, and we'll have some boards for you to solder. All right, so let's dive in here. So I have the circuit simulator opened here, and I've opened one that I've already built before. So this is a cell phone. It's called a cell phone charger. It's really I modified it. It's not really a cell phone. It's really designed to directly charge a lithium-ion battery, like one that maybe just a single cell lithium-ion battery. Maybe it's used for like a remote control car or something of that nature. It would be the battery inside your cell phone, but it would be like charging the battery inside your cell phone without it being in your cell phone, because part of the circuit is a charge controller, which you need for lithium-ion batteries. But cell phones have those built into the cell phone, so you don't have to worry about them in a power supply. So let's go ahead and just go through. So this circuit's going to be a lot bigger than our first one that we'll lay out, but I want to show you what kind of our goal is to be getting. And this is still a simple circuit. This is not complicated um, compared to what you can do in industry. All right, so first here I have a schematic here, and this has been labeled AC to DC. So this circuit right here converts AC to DC. And you can see here, I have things in the circuit diagram. This is not designed to simulate. This is clearly like, an AC plug. It's actually labeled as a male one. You can also put a female one there too. And then there's a fuse here. There's a transformer, but none of these, like this plug and this fuse here, are not things you can simulate. They are just symbols for us to be able to lay out circuits so that we can actually then construct them and have them. Because we would never simulate something like this. If we wanted to simulate the wall, what we would do is instead put that sine wave at 120 volts and 660 hertz. We wouldn't have this here. So this, nothing to do. And you can see here I've labeled different things here as far as different networks and everything. And so basically what comes out of this transformer, everything, I get a DC signal that's at 15 volts. Then I'm throwing it through a 317 regulator, and I believe I'm getting 9 volts out here, or it's either 9 or 6. I don't remember what I designed it at. And then there's this little connection here, says DC. Well, that means it actually just connects to another circuit, and it connects to the charge controller. And you can see this circuit is fairly complex here, it looks like. Now this is actually, I only designed portions of it. This is something where the BQ2000 is a chip that you can get. And, a lot of times when you're looking at these chips, they'll have kind of a schematic laid out on how to use the chip, because all of these components around this chip are really just to use this chip so that you can actually use it to determine things. Just to give you a little hint on some of the things here, this right here is just an LED. That's just to show you basically if it's charging or not. So you can have the LED on or off, like to know whether it's fully charged or not. This is the DC signal that's coming in, and then this is basically what's going out to the battery. And there are some things here that look a little weird, like I'm going to zoom in here, and I said there's like things that sometimes it doesn't really make sense as far as a resistor. There's this 0.05 ohm resistor. That is actually absolutely a 0.05 ohm resistor that's in the circuit, and it's got to be a very precise resistor too. This resistor is, I think it was like $2 or $3 per resistor, just because it's such a small resistance and you need it to be very accurate. And that's for current sensing for this particular circuit. So we have a lot of different components here as well, then this chip, and then this actually here, this therm here is actually so that the danger with lithium ion batteries in general is that, and you've actually may have heard of this in the news, is they can overheat and explode, or overheat and catch things on fire. And so this is actually designed to be like where you add in a temperature sensor, like a thermistor is what it is, a resistor that has its resistance varied based off of temperature. And you can bypass that as well, but we actually put in the thermistor here so that you could put it on the battery to make sure that when you're charging it, you didn't overheat the battery. And then this last one was just some connections to the actual jumper that's going to go to the battery for charging. So all of these circuit diagrams are all connected together. And then once you have that, we're not simulating any of these things. I didn't simulate any one of these things here. But what I did do once I get back here is there's these things that are generated here, and we'll talk a bit more about these, but they're called net files. And I'll just double click on one. And they're text files, but they contain all of the information as far as all of the part numbers, the actual like footprints, which are the actual like what the part looks like physically. It contains all the connections as far as what things are connected to what, so those text files tell us all that information. Then we take those text files and we put them into a different application. We import them into an application, and this is the finished layout here. This is not showing all of the work that we'd have to do, but we take all of those, we place all the components down. In fact, let me open a different file. I can show you that. This is like placing all the components down. There's another one I can show you as well. This one has some of the components placed, not all of them, but these blue lines are actually showing then what's connected together. And you might say there's no blue lines to this, and that's because not all the parts have been put down. And so when I go back to the original one that I had, all of the blue lines are gone because I've made all those connections. But if I were to simply just delete this, for instance, you'll see that blue line comes back up here because it's saying, hey, I need to connect these together. And these yellow lines are copper traces, basically. It's basically what we need in order to get it so that when we solder all the components on, that the device would actually work. Now, one thing I want to point out here is that some of these lines are different thicknesses, and that actually has something that we'll talk about later in the semester, is that depending on how much current you're expecting to go through these traces, you need them to be thicker or thinner. If you have a lot of current going through and you have a very thin trace, so if you have a lot of current and a decent enough voltage on the line, you'll basically burn the trace out. It will overheat, and it will basically kind of melt / split apart. And so we have to be careful with that, or it could cause a fire, which would be even worse. So those are things that you have to consider when doing traces and doing layouts. A lot of stuff though, you're not going to have to worry about the precise thickness of it because, okay, well, whatever's going through there, the lines are plenty thick, but we can talk about that later on. Now, to get to this layout stage, you'll notice that there's all these little different shapes here. And R9, of course, stands for resistor 9. And so this is basically a resistor. And then Q3, this is a transistor. And you can see it's got a different kind of shape to it and a different configuration of pins. And then we even have this little component here, which is actually on the bottom side of the board. That's actually that 0.05 resistor that we had to have there. And so we've got all these different components, but somebody had to design these, these are all called footprints. Someone had to design these footprints so that we could actually then lay them out here. And I was the one, actually, I designed all these footprints that are on here. And some of the things I did with some of the footprints you can see is like this is a diode here, but I even kind of drew the shape of the symbol in here and even did a plus and a minus because it matters the direction that these things go. You won't see that on a lot of layouts, and some of that's because the layouts, once they're done, they're assembled by machine. Now, if you're assembling them by hand like we're going to be doing, it's good to have some of that reference to make sure you put the components in the correct way. But again, if they're assembled automatically by machines, which a lot of things are nowadays, actually most things are nowadays, you don't really have to worry about some of that, although sometimes they still put that information onto the diagram. All right, so how do we do a footprint? Well, a footprint, I'm not going to save that, is also something that you do in this program. And I'll open up a footprint. And let's see here. Which one do I want to open? Here, I'll do this one. Oh. I've picked one that I did in a newer version of it. So let me just pick that one, which I know. Okay, so this one's a fairly simple footprint, but basically what I did here is this is for a 3.5 millimeter barrel connector. So like, old school headsets, things like that. And yeah, go away. I don't care about that OneDrive. And so I actually designed it. It's got 3 terminals because it's got stereo, and then so you have the left and right and ground. And I just made it kind of a square because that's what it was. It was kind of a square, and so I made these boxes based off of the data sheet. Now, on top of this here, what I just selected, I mean, that's a pinhole, but that's something we then call a pad stack. So we first have to create footprints, but in order to create footprints, we need to have pad stacks. Okay, so then how do we create a pad stack? Well, that's when we go to an even different program here, and we have a pad stack, and this pad stack is where we can enter, like, for instance, this one is a 1 millimeter drill hole. And how do I know it's 1 millimeter? Well, I've got 1 here as far as diameter, and you can see my units are in millimeters. So it's a 1 millimeter hole. And there's some other things that we have to do. We have some design layers and things of that nature, which we'll talk about more in detail. And so that pad stack then is used to it. So the order that we're actually going to do, I kind of went, from the top down. We're going to start from the bottom up now here. So we have to first start with making pad stacks. Then once we get good at making pad stacks, which is what we're going to focus on this week, then we will graduate to making footprints. And then once we make footprints, we'll graduate to actually laying out the circuits and being able to then etch them on the etcher.